Hello everybody, welcome to this video which is about implementing single area OSPF version 2. So this is a lab and we're going to be looking at in task 1 configuring process IDs, and then in task 2 we'll be looking at the configuration of adjacencies. So there's plenty to cover in this in this lab, so let's get into the lab. So what we're going to be doing is configuring single area OSPF version 2 on 5 routes. Now, when the lab is finished, each route will be configured with the process ID and a unique router ID. So, firstly, configuring OSPF processes. Well, task 1.1. When configuring OSPF, you should first configure the OSPF process. On router 1, issue the necessary commands to configure an OSPF process with an ID of 100. What valid process IDs can you then configure on the other routes in the topology? So, a big question, but basically, we need to configure router 1 with a process ID of 100, and then we'll look at the next part of the questions about what valid process IDs can we then configure on the other routers. So, firstly, let's configure router 1 with a process ID of 100. So, if we go into our lab here, what we need to do firstly is open up router 1. Now we go into privileged exec mode, then we go into global configuration mode. Now we do a router OSPF 100. So this is to configure the process ID 100. So that's all what we need to do here, guys. Is just router OSPF 100, but you need to do that in global configuration mode. Now I'm going into see the OSPF configuration here using show IP OSPF, and we can see that the process ID is indeed 100. As you can see here, routing process OSPF 100. Okay, so that's the process ID there configured. That is something else. That is the router ID there. So the next part of the question was, what valid process IDs can we use? Well, there's a range. So we can have 1 to 6,535. So that is the valid process ID range. Now, it's important not to get this confused, right, with the area ID range, because that is something which is different. So this is different to this. We've got to remember that. The area ID range has it goes from 1 to approximately 4.2 billion. That is the exact number there. So process ID range, that's the area ID range. But yeah, we can have a process ID of anywhere between that range, and in fact, you can have the same process ID on multiple routers. That's something with process ID you can do. With router ID you can't, so don't try that with the router IDs, because that is going to completely mess up the topology. But with a process ID range, you can do that. You can have a process ID of 100 on all your routers if you wanted to. But an organization will normally follow some sort of convention. So, yeah, that's something important to remember. Now, going on to task 1.2, on router 2, 3, 4, and 5, configure an OSPF process. Now, on each router, we are going to use a process ID that matches the VLAN ID of the private network to which the router directly connects. Okay, so let's see this in action now. So, let's go into our lab, and now what we're going to do is here, look, you can see here VLAN 200, 300, 400, 500. So in our topology, you can see there we've got multiple routers there with different VLAN IDs. Now what we need to do is you go into router 2, and we're going to do router OSPF 200. Now we come out of that router configuration. We now do we come out of global configuration mode, and now what we're doing is router we see, sorry, I went quick there, but we could see there that the process ID has been changed to 200. Now same process here for router 3. So enable, now configure terminology, go into global configuration mode. Now what we're going to do is router OSPF 300. So that's the process ID there being configured process ID of 300. And now let's verify this. So show IP OSPF. Here we go. Routing process OSPF 300. Now 400. VLAN 400. Router 4. So we need to configure an OSPF process of 400. So again, going to privilege exec mode. Now go into global configuration mode. And then once we're going into global configuration mode, we can now start to configure the process ID of 400. So now, come out of the global configuration mode, we can see if we do show IP OSPF, we'll see a process ID of 400. And there we go. So routing process OSPF 400 with ID 172.16.1.4. Now, finally, same process again for router 5, last but not least. So go into privilege exec mode. Now go into global configuration mode. And router OSPF 500. Okay, so now we come out there. Come out global configuration mode. Show IP OSPF. Routing process OSPF 500. So we can see we've got a process ID of 500 there as well. So that's configured now. Process ID is configured now on all 5 routers. So what benefit is there to configuring an OSPF process ID to match the VLAN numbers? You might be thinking that, what was the point of doing that? What is the benefit of doing that? Well, it's really about simplicity and just making less administration for the network administrators. So process ID, though, could also match the router ID. But when you do something like this, it makes the network more simpler to manage, less administration, or less administrative overhead, to be more exact, really. But yeah, I think simpler management, less administrative overhead. So those are the reasons you can do that. But you don't have to follow the VLAN ID. You could match the router ID instead. So you've got options there. Now on task 1.3, what we need to do is on route 1, issue the commands to display summary of the interfaces that are configured on the router. Now, based on the output, we need to identify which IP address do we think has been configured as the router ID and what is the purpose of router ID. So let's go into the lab now. So in the lab, let's come out of this mode and let's do show IP interface brief. So this gives us a summary of the interfaces. Now we want to identify what becomes the route ID, and here you can see a loopback address 172.16.1.1. And remember, the rule is, look, if you've not got a manually configured router ID, then what do we use? We look at is going to be the highest loopback address, and if you don't have a loopback address, the highest physical address. In this case, we do have a loopback address 172.16.1.1. We have a loopback interface, so we got a loopback interface. That IP address is then used. The highest, if here we only have one, so that automatically wins. If there were 2 or 3 loopback interfaces, then the highest IP address of them all would become the router ID. And if we don't have any loopback interfaces, then the highest physical the IP address of the highest IP address of the physical interfaces. Sorry, again, my tongue twisted there. The highest IP address of the physical interfaces would become the router ID. Now, so here's an in-depth answer there, but we can see, look, based on the output, you surmise that the IP address of 172.16.1.1 is most likely to be assigned as the OSPF router ID for router 1. This is because a router ID has not been manually configured on router 1, and the loopback zeros and the loopback zeros interface IP address is the highest IP address that is assigned to a loopback interface on the router. A router ID is a 32-bit unique identifier that resembles an IP address. Okay, it looks like an IP address. It's not an IP address. It's not an IP address, but it looks like one. Unlike the OSPF process ID, which is used to identify unique OSPF processes that are running on a single router, a router ID is used to uniquely identify the router itself in relation to the rest of the OSPF network. Therefore, each router in the OSPF network should have its own router ID. Okay, task 1.4. On router 1, issue the commands to display information about the OSPF process that is running on the router. Issue the command to display information about the OSPF process that is running on the router. What IP address has been selected as the router ID, and why? Okay, so we've already identified that. So here we go, 172.16.1.1. We can see that has been selected as the router ID, 172.16.1.1. Now, task 1.5. On router 1, issue the necessary commands to manually configure the OSPF process with the router ID 1.1.1.1. So, look, we can see what so what we're doing now is, instead of that leaving it to the router to automatically configure the router ID, we're going to manually do this now. We are going to manually do this ourselves. Now, what do we expect the immediate effect of the configuration to be on the router, on router 1? So, in other words, when we make this change, how's this change going to be? How's this change going to be processed? Is it going to, what's going to happen immediately after doing this? Will there be change? Will the change go through? Will it not? What action would you need to perform if you have already configured OSPF adjacencies on router 1? So, in this scenario, what would happen? It's a multi-faceted question here. So let's focus on the first part. Issue the necessary commands to manually configure the OSPF process with the router 1.1.1.1. So how do we manually configure a router ID? That's the question. Well, it's not that difficult. First, we've configured the process ID here, haven't we? Now, what we need to do is router-ID, and then put in the router ID that we want to use here. So router-ID 1.1.1.1, click enter, and that's the router ID there. That's it configured. However, when will that change take effect? When does it take effect? That's the question here. In this case, it would take effect immediately, because there are no other adjacencies here. We don't need to we don't need to do there's no other impact on other adjacencies, so we don't have, and so in this case it would take effect immediately, but the question here is asking if you'd already configured OSPF adjacencies. It'd be a bit different, because you would have to it'd be different. The configuration wanted to take effect immediately. There's a bit more. That's a little bit of a longer process. I won't go too much into that now. Let's go into task 1.6. On router 1, issue the command to display information about the OSPF process that is running on the router. Has the router indeed changed? Why or why not? So, if we go into the configuration now, so let's come out of global configuration mode to show IP OSPF. We can see that is taken effect immediately. It's taken effect immediately, so we verified that now as well. That's taken effect immediately. So it's important here, when we have multiple adjacencies, what I was just talking about, when we have multiple adjacencies, router IDs don't immediately take effect until we do something. What is that? Have a think if you don't know. Here it is. For the new router ID to take effect, we need to use the command clear IP OSPF process. This will cause any existing OSPF adjacencies to transition to the down state. The OSPF routers will then rebuild the adjacencies with new router ID. So existing adjacencies will need to go into the down state. We need to, after we do clear IP OSPF process. That is necessary when you have multiple adjacencies. So the OSPF routers will then rebuild the adjacencies with the new router ID. Right, now task 1.6 is done. Let's move on to task 1.7. Issue the necessary commands to manually configure router 2 with router ID 2.2.2.2, router 3 with router ID 3.3.3.3, router 4 with router ID 4.4.4.4, and router 5 finally with router ID 5.5.5.5. So, and also, this is task 1.8. We're going to do these together. So routers 2, 3, 4, and 5 issue the commands to display a summary of the OSPF process configured on each router. Each router currently configured with unique router ID. Let's have a look now. So let's go into the lab, and now let's start doing the actual configuration. So here we are. We're in router 2, and now we're in router 2. Let's configure the router ID. So look, we're already configured the process ID 200. Now we need to configure the router ID with 2222. Now let's come out to the global configuration mode and let's verify this. So show IP OSPF, and here look, we can see the ID has been straight away configured as 2222. Great. Let's do the same process on router 3. So let's come out. Let's go into global configuration mode, router OSPF 300, router dash ID 3.3.3.3. So go into privilege exact mode, show IP OSPF. We can see the process ID 300, ID 3333. Great. Right, now router 4. Again, router dash ID 4444, show IP OSPF. Let's verify it, and there we have it. 4444 is the router ID. Finally, router 5, router dash ID 5555. Great. Privilege exec mode, show IP OSPF routing process with OSPF 500 with ID 5555. Excellent. Okay, so we've got router IDs. They're all configured for all 4 of those routers. Brilliant. Perfect. So from task now finally task 1.9, from router 1, attempt to ping router 5's loopback 0 interface 172.16.1.5. Does the ping succeed? Why or why not? So let's try this now. Router 1, ping 172.16.1.5, and it looks like the request is timing out. Okay, so that ping failed. So why did the ping fail? That's the question here. The answer is actually really simple. So why can't router 1 ping router 5's loopback interface, you ask? It's simple because there's no route for router 5 in router 1's routing table. It's very simple there. Sorry, I said finally. There's we're not just quite done yet on task 1. On router 1, issue the command to display the routing table. Why have no OSPF routes being inserted into the routing table, even though you have configured OSPF process on each router? So let's do this now. So show IP route. So when you look at the codes, by the way, you'll see O is OSPF. You can't see any of those here. So this, we don't see any OSPF routes in our routing table at the moment. But also the answer is simple. The reason that we don't have the reason for this is because simply that process of exchanging routes, OSPF routes, has just not happened yet. We've not gotten to that stage yet. So yeah, processes have been configured, but the routes haven't been exchanged yet. They're not been. So that's why. But in task 2, you'll see this change. So let's go on to task 2 now. So task 2 is all about configuring OSPF version 2 adjacencies. So let's quickly look at wildcard masks. So yes, there's a word I really dislike, but a point needs to be emphasized. So I don't like this word. I do not like this word. So normally used in a negative sense, and more than often to put people down from pursuing their dreams, aspirations, goals. However, you cannot be comfortable with wildcard masks if you can't determine the subnet mask and wildcard by looking at an interface's IP address and mask. So it's very important that we are comfortable with wildcard masks, and to be comfortable with coupling with us, comfortable with our subnetting masks, subnet masks, and be able to read and interpret them. So this is something important I wanted to highlight. So wildcard masks, if I could put it down in as simple as I can, it'd probably be this, which is 0 is used to compare, 255 is used to ignore. Okay, to put what wildcard masks are a way to tell a router how to search for how to match, how to compare, how to match an interface to configure into an area. So 0 is used for comparison, comparing octets. 255 is telling the router ignore this octet. So that's very important. The golden rule: wildcard masks is always the block size minus 1. So block size, by the way, block size is so it's 256 minus the minus the final octet in the in your subnet. So that's the block size. So it's always the block size minus 1. So that's a good way of remembering of remembering how we can quickly find the wildcard mask. So yeah, the block size 256 minus your subnet mask. For example, you've got a subnet mask on 245.245.245.248. The final octet in that subnet mask 248. 256 minus 248 is gives you 8. That's the block size of 8. The wildcard mask would be 7. So let's go in now finally into task 2.1. So on router 1, issue the commands to configure OSPF process 100 to advertise every network that is configured on the router in area 0. Issue the commands to configure OSPF process 100 to advertise every network that is configured on the router in area 0. Use the most specific wildcard mask for each network. How did you calculate the wildcard masks? Okay, so what we're going to use is the network command. The network command to configure OSPF process 100 to be able to basically tell the router to put the IP addresses that I'm telling you into area, to put those IP addresses for those interfaces into area 0. So let's do show IP interface brief here. We can see that is a capture of currently what interfaces we have on the router. So these are the interfaces that we need to tell our router by using the network command to add to configure into area 0. Okay, so those are the IPs and subnet masks that we have here. Those are the interfaces. We are going to tell our router that, hey, we want to configure these into area 0. So what do you need to do? Firstly, I'll just show you how to get up that screen, how to get the interfaces. So again, show IP interface brief. Those are our interfaces here. 000, fast 10, fast 2, /0, it's loopback 0. We need to use the network command in order to add those into, configure those interfaces into area 0. So we've gone router OSPF 100, process ID 100, network. Now we're specifying the interface it's the IP of the of 000, and now we're using a wildcard mask here of 0003, and now finally define the area 0. So that's telling our router we've got this interface 000. It's got an IP address of this 230.1.1.3 and wildcard mask 0003. Put this into area 0. Same process now with the second interface, which is fast Ethernet 1/0. That also has the same wildcard mask. Now moving on to fast Ethernet 2/0, 192.168.1.101.1, and put in the wildcard mask 000.15 area 0. So that had a subnet mask 255.255.240. So to calculate the subnet wildcard mask would be 256 minus 240, then minus that would be 241, and then minus 1. 172.16.1.1.0.0.0.0 area 0. So this is an exact match we're doing here for the last interface, the loopback 0, and that is now all 4 of those interfaces are now being configured into area 0. So on router 2 now, we need to issue the commands to configure each active interface to participate in OSPF process 200 area 0. Excuse me. Issue the commands to configure each active interface to participate in OSPF process 200 area 0. You should issue the relevant commands from the interface configuration mode. So we're going to do this a different way now. We're going to, instead of using the network commands, we're going to use the interface commands, right? We're going to use the interface commands in order to configure each active interface to participate in OSPF process ID 200 and configure them into area 0. We are pointing the interfaces, those active interfaces on router 2 into area 0. Yeah, in simple words. Now, let's go into that configuration now. So, show IP interface brief. So here we can see the interfaces we've got on router 2, the active interfaces. So what do we need to do now is, we've got these 4 interfaces. We want configure these into area 0. So let's go to configuration mode, but here this time we use the interface subcommand. So what do we do? Interface serial 00. You'll find this is also easier as well. This is easier than doing this the network command way, because we don't have to calculate wildcard masks here. We specify the interface, and now IP OSPF 200. So remember, IP OSPF, then you put the process ID and then the area and then the area ID after. So IP OSPF 200 area 0 exit. Now that's done for the first interface. Let's go into the next interface 0/1. So serial 0/1. Go into the interface. Now we're in the interface configuration mode there. Oh, by the way, here you can see that neighbor relationship as they're formed for 0/0. So that's beautiful. Now, if you look at the topology, router 2, you can see here it's got a serial linked with router 1 connection there. Just wanted to point that out. Now, if we go back into 0/01, now let's actually configure the process ID and configure that into area 0. IP OSPF 200 area 0. Now, what's next? Fast Ethernet 1/0. Fast Ethernet 1/0. So what we're doing now is interface fast Ethernet 1/0. Go into the interface configuration mode, and now IP OSPF 200 area 0 as before. And then we just need to do this finally for the last interface loopback 0. So, oops. typo there. Right, interface loopback 0. Interface loopback 0. Now, IP, OSPF 200, area 0. Okay, great. So that's process ID 200, area ID there configured. Come out now, and great. So that's now been configured now for all those interfaces. Beautiful. So let's move on. What prerequisites must be met for OSPF routers to establish an adjacency? What prerequisites must be met for OSPF routers to establish an adjacency? Remember, there are things that need to be met. There are conditions in order for adjacencies to form. So 6 things I want to point out here. 6 things. Matching load timer, matching dead timer, same subnet mask, same area ID, authentication password, and the advertised networks, including the IP address. The advertised networks need to include the IP address of the interface. The advertised networks need to include the interface of they need to include the IP address of the interface connected to the neighboring router. So those are 6 things we need to remember now. So on task 2.3 on router 2 issued the commands to display information about OSPF neighbor relationships that exist on the router. Router 2 issued the commands to display information about OSPF neighbor relationships that exist on the router. Which routers has router 2 formed relationships? In what state is the relationship? So we need to display information about the OSPF neighbor relationships that exist on the router, and with which routers has router 2 formed the relationships, and then in what state is the relationships. So firstly, show IP OSPF neighbor. Here we can see the neighbor relationship there, 1111. So that's router 1. Okay, state //. So remember, this is serial. That's serial interface there. So look at the state. Full. So there's no designator or backup designator because this is a non-broadcast multi-access network. Sorry for the typo there. That's involving serial interfaces. It's not a broadcast network type here. So there's no designated router. There's no backup designated router. So therefore, the state you'll see // the full relationship there, but there's no designated to backup designated router. Sometimes you'll see full /DR, and okay, but those are in broadcast network types. So task 2.4 on router 3 issued the commands to configure the fast Ethernet 0/0 interface 203.0.113.10 to participate in OSPF process 300 and advertises its network in area 0. Need to issue the commands to configure fast Ethernet 0/0 interface 203.0.113.10 to participate in OSPF process 300. It needs to participate in this process and advertise its network in area 0. So this is router 3 now, okay? We've done router 1, router 2. Router 3, we need to configure that interface to participate in those process 300 and notify its network in area 0. Next, repeatedly issue the show IP OSPF neighbor command to watch the designated router and the backup designated router election process. And which router is the designated router for the relationship that is established between router 1 and router 3? We need to talk about that as well. So repeatedly issue the show IP OSPF neighbor command to watch the designated router and the backup designated router election process. Okay, which router is the designated router for the relationship that's established between router 1 and router 3? Okay, this is a different network type than router 1, router 2, where we had a point-to-point network type. Okay, because there was serial interfaces and serial interfaces your two serial interface together, that's going to form a point-to-point network type there. There's no designator, back designator router. But here it's different. Router 1, router 3, but here we've got a different network type. Okay, a broadcast network type. So, configure the fast Ethernet 0/0 interface. Okay, to participate in process 300 and network and its network in area 0. So, similar to what we did in router 2, we need to do in router 3 using interface subcommands. So let's go into the interface configuration mode, and let's if we look at the IP address here, first one, fast Ethernet 00. What do we need to do now is we need to configure that to area 0, process ID of 300. Sorry for the loud air conditioning there. So it's getting quite warm in where I am. So router 3, configure terminal, router OSPF 300. Now interface fast Ethernet 0/0. So remember, we specify the interface when we're doing the interface subcommand way. And in my opinion, and I think probably most technical engineers would agree, this is the easier way of configuring. But in the real in a production environment, you would probably be using both. It just depends on the scenario. So here, IP OSPF 300 area 0. So that is now configured. Process ID 300 and fast Ethernet 00 as a is configured into area 0 there. So if you were to look at the, if you were to repeatedly do show IP OSPF neighbor, you would see that the neighbor, apologies, let's go back in, here we go. So sorry about this, what's going on? Okay, so this is not going well for me. Okay, right, we're back. So next, so here you can see that look at the neighbor states. If you repeatedly to do show IP OSPF neighbor, you'd see the states changing, and now you've got full /designated router state. Okay, so we have a transition from x dot dr to exchange dr to full dr, and now you can see that their neighbor relationship has changed. So on router 3, we need to issue the commands in interface configuration mode to configure the remaining active interfaces to participate in OSPF process 300 area 0. Okay, all the remaining interfaces now, and also why no neighbor relationships formed after these interfaces are configured. So there's a two-part question there. So let's configure the rest of the interfaces into with a process ID of 300 and area 0. So 3 more interfaces, and okay, so